Right now, your phone knows exactly where you are standing. You have probably never asked how. It just works. A blue dot appears and it is almost always right. But here's the strange part. The satellites your phone is listening to have no idea you exist. They cannot see you. They never receive a single signal back from you. They do not know your name, your street, or your country. So how does the dot know? The answer is that GPS is not a mapping system. It never was. Every satellite in the constellation is doing exactly one thing over and over forever. It is announcing the time. That is the entire broadcast. A precise moment stamped and shouted into space again and again, along with a note about where the satellite was when it shouted. Your phone catches that signal and compares the timestamp against its own idea of now. The gap is tiny, a few hundredths of a second. But radio waves travel at the speed of light, which means about 30 centimeters every nanosecond, so that tiny gap becomes a distance. Your phone now knows it sits somewhere on an invisible sphere around that satellite. Catch a second satellite and the possibilities shrink to a ring. A third narrows it to a point. But there is a problem hiding in that arithmetic, and solving it is where the whole thing gets beautiful. The satellites carry atomic clocks. Your phone carries a cheap quartz crystal, the same kind of thing found in a supermarket wristwatch. It drifts. And a drift of 1/1,000,000th of a second becomes an error of 300 meters. So how does a cheap clock ever produce an accurate position? It does not. It gets corrected. Your phone listens to a fourth satellite, and instead of treating its own clock as truth, it treats its own clock as an unknown and solves for it, alongside latitude, longitude, and altitude. 4 equations. 4 answers. One of them is where you are. One of them is what time it is. Sit with that for a second. Every device receiving GPS is not just locating itself. It is quietly disciplining its own clock against atomic time in orbit several times a second for free. There are billions of these devices, which means the world is now saturated with objects that know the time to a precision that barely existed within living memory. Because atomic timekeeping is young. In 1955, at the National Physical Laboratory in England, Louis Essen and Jack Perry built the first cesium atomic clock accurate enough to be practical, measuring time by the unwavering vibration of an atom rather than the swing of a pendulum. Within a couple of decades, the second itself was redefined around that vibration. Time stopped being something you read off the sky and became something you counted inside matter. Then relativity showed up and made everything harder. The satellites orbit roughly 20,000 kilometers above you, moving at several kilometers per second. Einstein predicted 2 competing effects. Their speed makes their clocks tick slower than yours by about 7 microseconds a day. Their distance from Earth's gravity makes them tick faster by about 45. The net result is that a GPS clock runs roughly 38 millionths of a second fast every single day. Sounds harmless. It is not. Left uncorrected, that drift would push your position off by something like 10 kilometers per day. Engineers deliberately detune the clocks before launch so that once they reach orbit, relativity nudges them into agreement with the ground. Your navigation app works because a theory from 1915 is being compensated for above your head, continuously, right now. The people who assembled this were not trying to build a map either. At the Naval Research Laboratory, Roger Easton developed a program called Timation, built on the idea that satellites broadcasting precise time could let a silent receiver work out its own position without ever transmitting. Bradford Parkinson later led the program that fused competing approaches into the system we now call GPS. And at the Naval Surface Warfare Center in Dahlgren, the mathematician Gladys West spent years programming the calculations that modeled the true shape of the Earth, because a position is meaningless unless you know the precise form of the thing you are standing on. Their machine escaped almost immediately, and the part of it that escaped hardest was not navigation. Think about a mobile phone call that stays connected as you drive between towers. Those towers must agree on timing precisely enough to hand you over mid-sentence, and many of them get that timing from the sky. Think about the electricity grid, where sensors sample the alternating current waveform dozens of times a second across an entire continent. Comparing those waveforms only reveals stress on the network if every measurement carries a timestamp everyone trusts. Think about financial markets, where regulators require trade timestamps traceable to universal time, because the order of two events microseconds apart determines who owns what. None of those systems care where they are. They care when they are, and they are all drinking from the same well. So what happens when the well is contaminated? On the 26th of January 2016, an old satellite was being retired. A software error meant a set of satellites began broadcasting a timing correction that was wrong by about 13 millionths of a second. It lasted hours. Almost nobody's blue dot moved noticeably. But telecommunications equipment threw alarms, and some digital radio broadcasting was disrupted across multiple continents. That is the whole story of GPS in one incident. The navigation barely flinched. The timekeeping wobbled, and infrastructure that has nothing to do with maps started failing. The signals themselves are astonishingly faint by the time they arrive, weaker than the background noise around them, which is why a modest jammer can blank them locally and why several countries are now rebuilding ground-based timing backups they had already begun dismantling. A system designed for guiding vehicles quietly became the heartbeat that industrial civilization synchronizes to, and almost nobody made that decision on purpose. Which brings us back to the dot. Your phone does not know where you are. It never did. It knows what time it is according to atoms in orbit, corrected for relativity, and it reasons backwards from that until only one place on Earth fits the answer. You are not being watched from space. You are being told the time over and over by machines that have never heard of you.